As any jaded high schooler knows, cosine 0 equals 1. But what happens if we keep taking the cosine of the answer? This is a much less well-known phenomenon. Let's see what happens. Speed this up a bit. We actually ran out of decimal places, so let's go to 8 decimal places. As you can see, this actually approaches a number. Let's see why this happens. Setting this phenomena equal to an equation, we can find out what this number approaches by taking the cosine of a number an infinite amount of times and setting it equal to x. But we could also say that since there is an infinite number of cosines, x can be considered the cosines inside the first cosine. By substituting x for these, we get the equation cosine x equals x. Let's graph this to see if we can find some sort of solution for x. First, let's graph cosine of x from 0 to 4. Next, let's graph x from 0 to 4 and mark the intersection point. That's the point we want to find. Let's zoom in on that point. Now, I'm going to mark the intersection and label it. It turns out that that point was actually 0.739, our original answer to the equation. Now this number is actually called a Dottie number, and is what we call a transcendental number. This means it cannot be solved with the roots of a polynomial equation. Pi and Euler's number are also other examples of transcendental numbers. So it turns out that an infinite number of cosines actually approaches 0.739085, etc. If you want to learn more about this and how to solve it analytically, check out Flammable Math's video cosine x equals x, linked in the description below. That's all from me. Thank you all, and goodbye.